Right, so in this section we're working with log notation, sort of manipulating between and understanding the relationship between exponentials and logs. Okay, keep in mind that the relationship between exponentials and logs is sort of similar to addition and subtraction. They undo each other. So just like a long time ago, you might have learned, let's say that 21 plus 4 equals 25, okay? And then one reason or one way you could think about it is, well, 21 is 25 minus 4. So you can either add the 4 and then to get to 25 or subtract the 4 to get back to 21. These two equations obviously mean exactly the same thing, but they're written a little bit differently, kind of showing a relationship between addition and subtraction. So in a similar way, we do this with exponentials and logs. So again, this is written as an exponential. It's clear to all of us that 4 cubed is 64, 4 times 4 times 4. Okay, but another way to think about it is with logs. So again, the key is don't lose sight of the base. We've always called 4 the base, 3 is the exponent, okay? So when we convert to exponential, we use 4 as the base. So it becomes log base 4, okay? And then again, we switch the roles. So here how 21, 25 kind of get switched. This would be the log base 4 of 64, so it will equal 3. Okay. So here base is 2. So if I have an exponential base 2, there's an equivalent log base 2. Okay. In this case, it would be of 32 equals 2. And then finally here, log base 3. Okay, so remember in this case, negative 4 is going into the exponential. Out pops 1 over 81. So if I'm using log, I would put in 1 over 81. And out would pop the negative 4. Okay. We can use some of this to help us solve some equations. Now, by the time you get to the end of this chapter, you'll be solving a lot of different kinds of equations. So you kind of have to take a step back and look and see what we're doing here. Now, this is sort of an odd one because I'm asking you to solve, but in a way, x is already solved for, right? X equals that. With a little manipulation, though, we could figure out exactly what is log base 8 of 4, okay? So when you typically say solve, I need to know what x equals, and I am giving you what x equals, but I have no idea how much log base 8 of 4 is. Okay, so if we manipulate a little bit, rewrite it, we can figure it out. So again, this is a log, so now we're doing the reverse of what we did up here, but the base is 8. So 8 to the x then has to equal 4. Okay, this is one of those type 1 equations from the last section from 5.2, because 8 can be written as base 2 and so can 4. So 8 is 2 cubed, 4 is 2 squared. Okay, so the left side is 2 to the 3x, the right side is 2 squared, and so we can equate the variables, the exponents. And so x is 2/3. It's a little bit better answer than x is log base 8 of 4. Okay. Number 2, we clearly have some work to do if we're going to solve for x, because right now it's stuck in the base of the log. Okay, so we have to get it out of there. So we use exponentials, and again, base log becomes base to the exponential, so it'll be x to the 4th equals 32. Okay, and then it's not a square root of cube, it's not x squared or x cubed, so we need a 4th root. So we take the 4th root of x to the 4th is the 4th root of 32. Okay, keep in mind we typically need to take a plus or minus square root, but 4th root, even root, but it's a base here, so it has to be positive. So x is just going to be the 4th root of 32. Okay. All right, one more of these equations. So here the x is stuck inside the log. Okay, so we can use exponentials to get it out. Base is 2. So when I convert to exponentials, it's 2 to the negative 3 equals x, which is great because now x is by itself. X is done. 2 to the negative 3, remember, is 1 over 2 cubed, or x equals 1/8. All right. Next part here, we're rewriting and start using our log properties. Okay, so it's important that you understand how to use some log properties to rewrite expressions. It works best with products and quotients. Okay, it also works with powers. Okay, this one you might say, I don't know what it's going to do here. Okay, but products and quotients, we don't want to see 8 plus x. There's nothing we would be able to do to log of 8 plus x. Okay, but one of the properties for log of a product is you can split it into 2 logs being added. division, so it's the log of the quotient, so it would be log, in this case, of the numerator minus log of the denominator. Okay. Clearly not a product or quotient, okay, but it is a power, right? Roots can be written as, instead of square root, 8 to the 1/2. Okay. And this is another log property that says if you have the log of some expression all raised to a power, that power can come down in front. So it'd be 1/2 times the log of 8. Okay. All right, and then this one, again, it doesn't really look like a product or quotient. Okay, we can manipulate it a little bit and say, instead of log of 0.1, think of it as 1/10. So I'll just rewrite the decimal as a fraction. Now it looks like number 2, so it could be the log of the numerator minus the log of the denominator. Okay, and these are two special logs. We know the log, no matter what the base is, this is clearly log base 10, but log any base of 1 is 0. And then remember, since this is base 10, when the bases match, that would be 1. And so we just get -1. All right, a few more to rewrite. Again, this is just a log property. We don't use it that often, okay? But 2 to the log base 2 of 7 is just going to be 7. And this is one property you want to remember. I believe it's property 3, okay? Again, we have a quotient, right, fraction, but we also have a product in our denominator, okay? But again, it's x divided by this. So first we do log x minus log of the denominator. And then we can separate this product. Now again, just be careful because it's minus the whole thing. So it's log y plus log z. So you can leave it like this, or you can distribute that minus sign. Okay. This one, again, much more going on here. We're going to have a power because of the big square root, which we'll call 1/2 power. We have lots of powers inside, quotients, products. So again, you just have to be a little bit careful about how you rip it apart. The first thing I would do, though, is write it all to a power of 1/2 instead of the square root. Okay, we can't get inside the parentheses until we deal with the 1/2. So we bring the 1/2 down first. And now we can do this, but again, we can't get into the denominator until, or into the numerator here, until we split up the fraction. Again, be a little bit careful. You got to do 1/2 times a product here. So 1 ln of the numerator minus denominator. Now we can get in there and split up that product. So it's log of the first plus log of the second. We still have minus ln z to the 4th. And finally, we can bring down all those exponents. So 3 ln x plus 5 ln y minus 4 ln z. And then if you want, you can distribute the 1/2. All right, now a few that we're going to put them back together, okay, instead of ripping them apart. So we have 3 logs added, subtracted. So again, you could do it one at a time, or you could try to smash this all together, but I'm going to do these 2 first. Okay, so the log of a sum, if I want to combine it, then is x times x plus 2. Keep in mind we still have the log 2. So log minus log becomes a division. And we get the log of x plus 2 all over 2. Again, this is not log minus log for the next problem. It's 2 log minus 3 log. There's no property that lets us handle that. So first we have to take care of the 2, so it can come up as the log of m squared. This can come up as the log of n cubed. Now log minus log, right, is a quotient, m squared over n cubed. Okay. Similarly here, right, we have lots of logs added and subtracted, but they have coefficients. Right, we have to deal with the coefficients first. So log of p to the 1/2 plus ln, be careful with your parentheses here, 2p to the 3/2. And then no coefficient here, coefficient is already 1. Okay. Now again, I'll do this one at a time. So I'll combine these two. 2 logs added would be 1 log multiplied, so p to the 1/2 times 2p to the 3/2. Still have this guy. Okay. I'm going to clean this up a little bit. We got a little bit going on here. So this is p to the 1/2, 2 to the 3/2, and p to the 3/2. Okay, so I combine those p's. So 1/2 plus 3/2 is 2. So it's p squared 2 to the 3/2 minus ln m squared p. Right, and now I can finally combine these two. Log minus log becomes 1 log divided. So I have p squared 2 to the 3/2 over m squared p. And I can cancel a little bit, right? I have a p squared on top, a p to the first in the bottom. And so that would just be a p up on top. And it would wind up like this. Okay, and then just a couple last ones here. It's kind of important for these last two, because what you'll notice is they can't really be simplified. So in this one, you have log 4 times log 7. Okay, that we have no property that deals with that. So there's no way to rewrite it. Same thing here. Okay, again, just keep in mind what I'm trying to make sure you realize is if you have the log 4 plus log 7, you absolutely have a way to combine those. It would be log of 4 times 7 or log of 28. That's not what we have. It's a completely different problem than this. Okay, similarly here. Okay, so there's no way that you would necessarily simplify that problem.